conjugate of surds. Let's say, for example, you have root 2 plus root 3. The conjugate is root 2 minus root 3. That you change the sign from positive to negative. Let's say we have root 2 minus root 3. The conjugate is root 2 plus root 3. It's all about changing the signs from positive to negative or from negative to positive. Let's take a third question. We have 2 root 2 minus 4 root 3. The conjugate is 2 root 2 plus 4 root 3. You just change the negative sign to the positive sign, and if it were positive, you change it from positive to negative. Let's take this next question that says minus 2 root 2 plus root 3. We have to find the conjugate. The conjugate is just changing the sign in the middle, or the sign owned by this root 3. It doesn't have anything to do with this negative sign that is owned by this 2 root 2. That's why this question is actually added. So we have the conjugate of minus 2 root 2 plus root 3 as minus 2 root 2 minus root 3. Note the negative sign of this 2 root 2 has not changed. The only sign that we have changed is this positive sign in front of this root 3. We've changed it from positive here to negative here. So when you talk about conjugate of surds, we're talking about changing the positive or the negative sign in the middle. You don't change the values or the numbers, just change the signs from negative to positive or from positive back to negative. That's what they call conjugate of surds. And it's very important in rationalizing surds, which is next in line. Rationalizing the denominator of surds. Next under surds is rationalizing the denominator. Let's say, for example, you have 2 over root 3. This can be compared to improper fractions under fractions, where you have, for example, 9 over 7. There you have to convert from improper fraction to mixed fraction. But in surds, you don't leave your final answer except in some cases with roots at the bottom. So we rationalize. We multiply by the same root at the numerator level and at the denominator level. We use the exact root of the denominator to multiply both the numerator and the denominator. So you have times root 3 times root 3. At the numerator you have 2 times root 3 as 2 root 3 over, you have a big root, then you have 3 times 3. Since they are both under roots, you can have it as 3 times 3. You have it as 2 root 3 over root 9. That's 3 times 3 is 9. 2 root 3 over root 9 is 3. This is actually your final answer. You've converted this from 2 over root 3 to 2 root 3 over 3. Second question. Let's say you have 2 over 3 root 3. You can't leave your answer like this. You have to multiply both the numerator and the denominator by the denominator with its roots. So you have times 3 over root 3 times 3 over root 3. Or you can take it 2 over 3 root 3 times just root 3 over root 3. They are linked by times, and you can therefore just work on this root 3. But if it were to be addition, it's a different ball game. So let's solve the 2 and see if we get the same answer. We have 2 times 3, that's 6 root 3 over 3 times 3, that's 9. Then root 3 times root 3 is same thing as 3 times 3. At this point, you can cut to the lowest term. You can say 3 here 1, 3 in 6, that's 2. Or you can multiply first, then you divide. So you have it as 2 root 3 over 9. That's your final answer. Let's try this where we just used only root 3. You have 2 times root 3, that's 2 root 3 over, this is a whole number, and this one also has 1 in front of it. So you have 3 times 1, that's 3. Root 3 times root 3 will give you 3, that's times 3. 3 times 1 is this 3, then root 3 times root 3 will give you 3. The one behind. You can jump to the next line. You have 2 root 3 over 3 times 3, that's 9. You have the same answer using 2 different techniques for the question. This method just helps you solve without having to simplify or cut to the lowest term. But this doesn't work for both addition and subtraction. The next question, question 3. Let's say you have 3 plus root 2 over root 3 minus root 5. What you're going to do is you consider the denominator, then you create its conjugate, which is root 3 plus root 5. Then you multiply both the numerator and the denominator by it. Also at the numerator level, you have root 3 plus root 5. This is also the same thing as 3 plus root 2 in bracket times root 3 plus root 5 in second bracket over root 3 minus root 5 in one bracket and root 3 plus root 5 in second bracket. We start with expanding the numerator. We have 3 plus root 2 in one bracket, and in the second bracket we have root 3 plus root 5. Expanding properly requires we take one of these two and repeat it twice. So let's take the one behind, which is root 3 plus root 5. Roll our line. We have root 3 plus root 5 in the first bracket, root 3 plus root 5 in the second bracket. We repeated this twice. The first gets this 3, we write it here. Then the second, which is this, gets this plus root 2. We have plus root 2. Because this root 2 owns this positive sign in front of it. For the denominator, if you have a very good eye, you will notice that this is a difference of two squares. In the sense that you have a minus b, a plus b, or a plus b, a minus b. What changes is the sign. One has a negative, the other has a positive, or the first has a positive, the second has a negative. The numeric values or the surds values are the same. This is a, this is a, and this is b, this is b. Same applies to this. This is root 3, this is root 3, this is root 5, this is root 5. One has a negative, one has a positive. And when it's in this case, if you are told to expand, the result is always a square minus b square. Now, we can use this to solve this question, but let's go through the normal route first, where we can either choose to repeat this root 3 minus root 5 twice, or this root 3 plus root 5 twice. Let's take the root 3 plus root 5 twice. We have in the first bracket root 3 plus root 5. In the second one, root 3 plus root 5. The root 3 gets the first root 3 plus root 5. Then the minus root 5 takes the second root 3 plus root 5 minus root 5. We move to the numerator. We expand. We have 3 times root 3 and 3 times root 5. These 3 affects both the root 3 and the root 5. Let's start with root 3 times root 3. Root 3 times root 3 is 3 root 3. By now, you should be very good with multiplying surds after watching multiplication of surds. So you have 3 times root 3 is 3 root 3. 3 times root 5 is 3 root 5. Then the plus root 2 times root 3 will give you plus root 6. That's both of them are in square root. So you take the square root, then you do 2 times 3, that's 6. Then you have plus root 2 times root 5 will give you root 10. That's both of them are in square root. You pick one of the roots, then you do 2 times 5, that's 10. Over at the denominator we have root 3 times root 3. Root 3 times root 3 is root 9. Square root of 9 is 3. So we have this as 3. Root 3 times root 5, or root 3 times plus root 5 will give you plus root 15. You should be very good with multiplying your surds now. You have root 3 times root 5, you pick one of the roots, then you multiply 3 times 5, you get 15. Then here you have to be very careful. A lot of students make mistake here. You don't just multiply the root 5 times the root 3. The root 5 owns a negative, and this root 3 owns a positive, although it's not visible. If it's not visible, it's positive and not negative sign. So you do the signs first. Negative times positive will give you negative. Then root 5 times root 3 will give you root 15. So we have minus root 15. If you make a mistake here, you get your answer wrong. Although you could get marks for method or for steps. Then you have minus root 5 times plus root 5. We go for the signs first. Negative times positive is negative. Then root 5 times root 5, since they are the same, having the same root, it's square root. And it's not that one is square root and one is cube root. Both are square roots and they are the same numeric values. So you just pick out 5. Root 5 times root 5 is root 25. Square root of 25 is 5. So we're on the right path. Next, we work with the numerator. Do we have like terms? I don't think so. Can we also break them down from the single form to the basic form? I don't think so. Because neither root 6 nor root 10 has a perfect square greater than 1 in it. So we leave our numerator as 3 root 3 plus 3 root 5 plus root 6 and root 10. There are no like terms. So at the numerator we have 3 root 3 plus 3 root 5 plus root 6 plus root 10 over. Now we collect like terms at the denominator. Let's take the constants or the pure numbers without roots first. we have 3, then this 5 owns this negative, minus 5, then you have plus root 15 minus root 15. The first root 15 has a positive, the second root 15 has a negative. On the next line, we still repeat our numerator, no like terms. 3 root 3 plus 3 root 5 plus root 6 plus root 10 over, this 3 has a positive, so plus 3 minus 5, you have 3, you are owing 5. If you pay back, you still be owing 2, because what you have is less than what you owe more than you have, so your result is minus 2. Then you have plus root 15 minus root 15, it's 0. It's like saying plus a minus a is 0, or saying plus 1 minus 1, which is same thing as 1 minus 1, 0. Any numeric value or mathematical symbol subtracting itself results in 0. A minus a is 0, 1 minus 1 is 0. So root 15 minus root 15 is 0. We don't need to write it here. And since there's nothing we can do to the numerator, this is our final answer. Our final answer is 3 root 3 plus 3 root 5 plus root 6 plus root 10 over minus 2. Remember, we talked about the denominator at this point as a difference of two squares. That means we can actually solve it using this formula or this method. The result is minus 2. So we're going to solve it using this technique to get negative 2 or minus 2. Let's say we separate the denominator from the whole question. We have root 3 minus root 5 in one bracket, root 3 plus root 5 in the second bracket. Now we're supposed to solve, and we want to solve it using this difference of two squares method to expand or to multiply or simplify. Note that there might be cases where you have the minus root 5 in front and the plus root 3 behind, but if you can arrange it or you can figure it out and mark that it's a difference of two squares, you can apply this in solving. Now your a, as in this case where you have a minus b, a plus b. A represents root 3 and b represents root 5. So we'll take a squared minus b squared. Root 3 is a, you square it, minus b is root 5, you square it. In this case, the square cancels the square root, you are left with 3 minus. Also in this case, the square cancels the square root, you are left with 5. We have 3 minus 5, that's minus 2. You can therefore see that we have the same result as expanding the standard way. We have minus 2 here and we have minus 2 here. But this method is shorter provided you understand what to do. Y question. This is a Y question and it says 8 minus 3 root 6 over 2 root 3 plus 3 root 2 expressed in form of m root 3 plus n root 2, where m and n are rational numbers. What the question is simply saying is convert this to this. And if you're very good with rationalizing, the question won't tell you to rationalize. The only way you can solve this question is by rationalizing. That's rationalizing the denominator. Let's write it out first. You have 8 minus 3 root 6 over 2 root 3 plus 3 root 2. To rationalize, you have to find the conjugate of the denominator and multiply it by both the denominator and the numerator. Finding the conjugate is easy, where you just have to change the sign from positive to negative, and if it were negative, you change it from negative to positive. But here it's positive, we're changing it to negative. You have times 2 root 3 minus 3 root 2, both at the denominator and at the numerator. We can rewrite as 8 minus 3 root 6 in bracket, in another bracket 2 root 3 minus 3 root 2 over 2 root 3 plus 3 root 2 in one bracket, 2 root 3 minus 3 root 2. Now, at the denominator, we have difference of two squares. You don't need to waste your time expanding if you know what you're supposed to do. It's like saying a minus b, a plus b, or a plus b, a minus b. They are both the same thing, means a squared minus b squared. Let's work with the numerator first. Let's repeat this. The first one gets 8, the second one gets the minus 3 root 6. You have 2 root 3 minus 3 root 2, the first one. Second one, 2 root 3 minus 3 root 2. Then first one gets the 8, this 8. Then second one gets the minus 3 root 6. When you have a negative, you have to be careful. Over. Now, at the denominator, since they are both the same values, the only difference is the positive and the negative, and they are multiplying themselves, you just apply difference of two squares, where this squared and this squared, and they are linked by minus. So you have 2 root 3 all squared minus 3 root 2 all squared. Let's go back to the numerator. You have 8 as a whole number and you have 2 as a whole number. You're multiplying the 8 by this and also by this. 8 times 2 is equals to 16 root 3. That's 8 times 2 root 3 is 16 root 3. Then 8 times minus 3 root 2. 8 as a positive, it's not really dangerous. Then you have 8 times 3, that's 24 root 2. Then you have minus 3 root 6 times plus 2 root 3. Minus times plus, this 2 root 3 has a plus, so you do minus times plus, that's minus. Then 2 times 3, 6. Then root 6 times root 3. Root 6 times root 3 is root 18. Then we'll go to the surds behind. You have minus times minus. This 3 root 2 owns this minus. So minus times minus is plus. Then see, it changes the sign to positive. Some students make mistake at this point. Then you have 3 times 3, that's 9. Then you have root 6 times root 2, that will give you root 12 over. You can jump on this. Your 2 can get its separate square and your root 3 can get its separate square. So you have 2 square, then root 3 squared minus 3 square, then root 2 square. Each of them gets their separate squares. We go down to the next line. You have 16 root 3 minus 24 root 2 minus, you have to be very sensitive here and know that this 18 has a perfect square greater than 1 in it, which is 9. Then you have 6 times 9 times 2. That's 9 times 2 is 18. So you have a perfect square, which is 9 there, plus 9. In this 12, we also have a perfect square greater than 1 in it, which is 4. Then you have 4 times 3 over 2 squared. 2 times 2, that's 4 times root 3 squared is the square cancels the square roots. You'll be left with 3. 4 times 3 minus 3 squared is 9. Then you have root 2 squared. The square cancels the square root. You'll be left with times 2. You can go on to say this equals 16 root 3 minus 24 root 2 minus 6. Then you can have times root 9 times root 2. You can give the 9 its separate square root and the 2 its separate square root, plus 9 times root 4. The 9 is linked to this by times, so you join it by times, then 4 gets its separate square root and 3 gets its separate square root, over 4 times 3, that's 12, minus 9 times 2, that's 18. You have 16 root 3 minus 24 root 2. Then you have minus 6 square root of 9 is 3 times 3 times root 2, it has a root 2 behind it, plus 9 times square root of 4 is 2 times root 3, over 12 minus 18 is minus 6. On the next line, we have 16 root 3 minus 24 root 2 minus 6 times 3, that's 18 root 2. Then you have plus 9 times 2, that's 18 root 3 over minus 6. On the next line, at the numerator level, we collect like terms. The ones with root 3 will come together and the ones with root 2 will come together. So we have it as 16 root 3, then this 18 root 3 owns this positive, then plus 18 root 3 minus 24 root 2 minus 18 root 2 over minus 6. The root 2's will come together. And from the question, it says you have it in the form where you have m root 3 plus n root 2. 16 root 3 plus 18 root 3, you pick one of the root 3's. 16 plus 18 is 34. Then you have minus 24 root 2 minus 18 root 2. You're owing on both sides. That will give you minus. Then you have your root 2. It will be minus 42 over minus 6. Now at this point, if you can't cancel out directly, you give them their separate minus 6 since they are linked by minus. And remember, we said in the aspect when we talked about division of surds, and no, this is from a further maths question and it's not straight math, but you can get the logic behind it. It's simple and just working with fractions at this point. You have 34 root 3 divided by minus 6. Then you have minus 42 root 2 divided by minus 6. Now we can say 2 here 3, 2 here 17. So we have this as 17 root 3 over 3. The 3 has a minus, you can leave it as minus 3. This is further maths question, but it's still understandable in math. Then at this other part, you start with the sign. Both of them have minuses. You have minus divided by minus will give you positive. Then you have 6 can go in 42. 6 in 6, 1. 6 in 42 is 7. So you have 7 root 2. You still have your root 2 here. You have the minus below, but you can move it up. It's allowed in math, you can move it up or you move it in front. So you have it as minus 17 over 3 root 3 plus 7 root 2. And equating to m root 3 plus n root 2. And we've been asked to find our m and n. Our m, the one with the root 3, m is the value in front, which is minus 17 over 3, and the n, which is the whole number or the rational whole number in front of root 2, and in this case is plus 7. These are our answers. That's m is minus 17 over 3 and n is plus 7, or we can say n is 7.